is recording. Yep, it's working. Is that when I go full screen, I can't see any questions that you may have. So the only drawback to online is you can't ask questions. I mean, you can type them in at the end of class when I shrink the screen, but as far as during class, you won't be able to ask them. Where in class you can. So it's the only drawback to it, but hopefully it doesn't bother you too much if you do have to go online. All right. Okay, so let's go ahead and get started with section 6.1. Make sure the, yep, double check just to make sure it didn't. Okay, so we're going to be looking at finding the area between two curves. Excuse me. So what if we let some function f of x and some function g of x represent two continuous curves? Or you can just say function. That's probably a more accurate description. Say functions. Okay. With those two functions, we know that one is always greater than the other, at least for a certain interval. Okay, so let's say such that, let me put that on the next line so I'm not squeezing it all over there. The function f of x is greater than or equal to the function g of x. Okay. Not over the entire interval, but just over an interval from a to b. So x equals a to x equals b. Okay. So what if we let R represent the region between those two functions? Bounded above by the function f of x. Bounded below by the function g of x. On the left by x is equal to some value a. And on the right by some value x is equal to b. Okay, then we know that the area of the region that we decided was uppercase R, given by the formula that area is equal to the integral from a to b of f of x minus g of x with respect to x. Okay, so all that means is that if you have on your xy axis some function f of x, we'll say this is f of x. Okay, and we know that that function is greater than or equal to some function g of x. We'll call this g of x. Okay, but only between some values x equals a and x equals b. So we'll say this is our x equals a and b. Okay, now they could crisscross outside of that. We don't care about that right now. We're just worried about between a and b. Okay. So we know between x equals a and x equals b is bounded from the left and right, bounded above by the function f of x and below by g of x, which means that this section right here that's the region R that we were looking for. If we want to find the area of that region, we just use that formula. Any questions on that one, or did that kind of sort of make sense? Okay, now just because f of x is first in the formula doesn't mean it always goes first when you're actually applying it. Okay, we'll move that down. So what if you have a function Let's say this function here is your f of x. Make that a little longer. Okay, let's say that this function here is your g of x. Now let's say we're still looking for the area between x equals a and x equals b. So that means we're looking for the area of this region plus the area of this region. Okay, so let's say we know that at some value c is where they intersect. Now, if they intersected outside of the interval, we wouldn't care. But just because the intersection was in the interval, now we have to actually adapt to that. So we know the greater of the functions will always be the first term. So for this interval from a to c, the integral from a to c, we see f of x is the greater function. So we know that this will be f of x minus g of x with respect to x. Okay, but we see that on this region, g of x is the greater function. So that'll be the integral from c to b. So it's g of x minus f of x with respect to x. Probably one of the most common errors is seeing the formula f of x minus g of x and thinking, okay, because they're going to give you f of x is this function and g of x is this function. And sometimes the g of x will go first because it's the greater function in that interval. So you don't want to always say that the f of x will go first because sometimes it doesn't. Because the f of x just represents a function or the greater function. All right, leave that up for a few more seconds. All right, anyone still writing? All right, here. Okay, so let's say, for example, if we have some region R, and sometimes they'll call it region R, Q, don't get mixed up if they throw a different region variable in there. R is the region. Bounded above by the function f of x is equal to negative 1/4 x minus 3. Bless you. And bounded below by the function g of x is equal to 1/4 x minus 8. Over the interval from -2 to 3. I want to find the exact value of the area of that region. Okay. Now, these questions are actually the easy ones because they tell you it's bounded above and bounded below by which function. Okay, so we already know the bounded above function will come first. Okay, so we know that since it is given that f of x is greater than or equal to g of x. And again, we knew that when it said it's bounded above. That tells us that f of x will go first. So it's going to be f of x minus g of x. So it's the first term. Uh-oh. So we know that the area of that region is going to be the interval from a to b of f of x minus g of x with respect to x. Okay, so that means our area is equal to the interval from -2 to 3. We know that -2 is our a, and that 3 is our b. So that's from -2 to 3 of f of x, which is -1/4 x minus 3, minus g of x. So that's minus 1/4 x minus 8 with respect to x. Now, if you wanted to, you could just distribute that integral and solve it that way, but normally I like to just simplify it in there so I can just integrate once. So we just have to go ahead and distribute that -1. So the area is equal to the integral from -2 to 3. That gives us -1/4 x minus 3. And make that 3 a little neater. There we go. -1 times 1/4 x is -1/4 x. -1 times -8, +8 with respect to x. All right, so we can go ahead and combine our like terms. So -1/4 x minus 1/4 x is just -2/4 x. So we can simplify that to just -1/2. -2 to 3, -1/2 x, and -3 plus 8, just make that +5. All right, so now we just go ahead and integrate both terms. Okay, so we have -1/2 times the integral of x, which is x squared over 2, plus the integral of a constant. It's just a constant times that independent variable, so that just becomes 5x. Okay, and that's from x is equal to -2 to 3. And then from there, we just apply the fundamental theorem. Plug in our upper bound, and we can just change that to -1/4 x squared. Actually, I'll simplify it first before I plug it in. 1/4 x squared plus 5x, just to avoid any confusion. And I'll plug it in there. Now we plug in our upper bound. So -1/4 times 3 squared plus 5 times 3 - minus, now we plug in our lower bound, negative 1/4 times negative 2 squared plus 5 times negative 2. Now from there, we just go ahead and simplify. We have 3 squared, which is 9 times negative 1/4, negative 9/4, plus 5 times 3, so that's plus 15. Minus, we have negative 2 squared, which is positive 4. Negative 1/4 times positive 4 is negative 1. But as soon as we distribute that negative, it becomes positive 1. Five times negative 2 is negative 10. But as soon as we distribute that negative 1, it becomes positive 10. And then from here, it's pretty straightforward. You have negative 9/4 plus 26. Or you can just rewrite it. Negative 9/4 plus 1/4/4 if we want to have the common denominator, which gives us 95/4. Okay, which is the area of that region. Right. Any questions on that one? And again, those are the easy ones when they tell you that it's bounded above by this, bounded below by that, because you don't have to figure it out. The ones that don't tell you, the way I normally did them, like on the homework and the regular chapter exams, is that I would just graph both of them on the same axis. And you can kind of see which one's above and which one's below. So you can figure it out that way. And that just a lot of times saved a lot of work. But on the final, since you won't be able to, with that one, we can still kind of see what questions will be on there. So 9 times out of 10, I'll probably use the graphing calculator on the final. Since it's not departmental, I can kind of make it up on my own. Departmental ones that I have no say so, with this one, I can kind of do it on. So I can be a little flexible on that one. All right, anyone still writing? All right. Okay, so let's say we know that R is the region bounded by the functions f of x equals negative 3/4 x squared minus 1/2 x plus 6, and the function g of x is equal to negative 1/2 x squared minus x plus 4. And we want to find the area of that region R. Now, only problem with this one is that they told us that it's bounded by the functions, but they didn't say which one bounds from above and which one bounds from below. Okay, so the first thing we have to do is we have to find which function bounds from above. If you also notice, we don't have an interval. So we have to find not only where it bounds from above and below, but we have to find the interval as well. Okay, we start off with finding where they intersect. Okay, so that means we have negative 3/4 x squared minus 1/2 x plus 6 is equal to negative 1/2 x squared minus x plus 4. Now, since we know these are both quadratic equations or quadratic functions, we can just set it equal to 0 and then just solve it that way. So we're going to add 1/2 x squared to both sides, but since this is a denominator of 4, we're going to change that 1/2 x squared to 2/4 x squared. Where those two cancel each other out. So we have minus x, so we want to combine it with this x term, but we need a denominator of 2. So we have minus x, which means we're going to add x to both sides, but we're going to add 2x over 2, which is the same as x. So those two cancel each other out. And we're going to subtract 4 from both sides. Those two cancel each other out. Okay, so now if we go ahead and simplify the left side, we have negative 3/4 plus 2/4, which is negative 1/4 x squared So negative 1/2 plus 2 over 2 is just positive 1/2. Or you can say negative 1/2 plus 1, same thing. And 6 minus 4 just gives us 2. Straighten that up a little bit. There we go. Okay. Now, if we wanted to, we could solve this using the A times C method. We could solve it using the quadratic formula. But with those fractions there, it's just going to get messy. So the easiest way to solve a problem with fractions is to get rid of the fractions. So we're going to go ahead and multiply each term by negative 4. So we have negative 4 times negative 1/4 x squared plus negative 4 times 1/2 x plus negative 4 times 2 is equal to negative 4 times 0. Okay, so negative 4 times negative 1/4, multiply those, you get 1. That just becomes x squared. Negative 4 times 1/2 is negative 2. So it's minus 2x. Negative 4 times 2 is negative 8. It's minus 8 is equal to negative 4 times 0 is just 0. Okay, so that one's a little bit easier to handle. Okay, so now just using the zero factor property, we just have to factor the left side. So we know x squared minus 2x minus 8 just simplifies to become x minus 4 times x plus 2 is equal to 0. Which means that x minus 4 can equal 0 and make that true. So x can equal 4. Or x plus 2 can equal 0 and make that true, which means x can equal negative 2. Right, so these are the two values where f of x is equal to g of x. Okay, so we know since they intersect at those two values, let me write a little f and g intersect. We know that our interval must be between those two values. Otherwise, because the graph will just go on and on forever outside of where they intersect, it'll just go on. So the area will basically be infinite. So from negative 2 to 4 is our interval. Okay. So now we know what the interval is. We just now have to figure out which function is the greater function in that interval. And that was pretty straightforward. So to find out which function is greater, we just plug in the test value. At test value, just pick one inside the interval. You can pick whatever test value you want. Me, whenever possible, always pick x equals 0. Just makes things easier. But you can pick -1, 1, whichever one you want to. Okay. So we see that f of 0, and bring that down. We plug in x equals 0. This term disappears. This term disappears. We're just left with 6. So f of 0 is equal to 6. And we do the same thing with g of 0. Look up, plug in x equals 0. This term disappears. This one disappears. You're just left with 4. Okay, so we know that just on this interval, since f of 0 is greater than or equal to g of 0, then that means for this interval, f of x is greater than or equal to g of x. For the interval from -2 to 4. So we know that since it is the greater function in that interval, then it has to be the first term. We'll finish this up on the next page. Anyone still writing? All right. So that means the area of that region, the integral from a to b, since f of x is the greater function, f of x minus g of x with respect to x. So that area is equal to, the integral is from -2 to 4. Oh, that up a little bit. Of f of x, which is -3/4 x squared minus 1/2 x plus 6 minus your g of x, which is -1/2 x squared minus x plus 4. Right, so again, now we have to do is simplify it by getting rid of the parentheses. Okay, so we know that's the integral from -2 to 4, -3/4 x squared minus 1/2 x plus 6 we distribute that negative, this becomes plus x squared plus x minus 4. Okay. So again, we can go ahead and just combine like terms. Combine our x squared terms, our x terms, and our constant terms. Okay, so that gives us the integral from -2 to 4, -3/4. Oh, did I forget? Yep, forgot my 2. 1/2 x squared. There we go. Knew something didn't look right. Okay, so 1/2 x squared times -3/4, that's -1/4 x squared. -1/2 x plus x, that's +1/2 x. And 6 minus 4 gives us 2 with respect to x. I'm going to show you a possible shortcut, and sometimes it works, sometimes it doesn't, but it's all depending on how lucky you get. I'm just going to cover this for 1 second. Now over here, when we brought everything over to the left side, basically we subtracted g of x. So it became f of x minus g of x. So if you notice, when we did that, we ended up with, where is it? Ah, here we go. This function here, because this is just f of x minus g of x. So that's why when we did f of x minus g of x here, we ended up with the exact same function. Now it depends on luck, because this could have easily been g of x minus f of x. So if you happen to have, oh, there you go, f of x minus g of x here, and you end up with f of x minus g of x, then you can kind of bypass all of this because you know it'll end up being just this function here. But I wouldn't automatically assume it because you still have to make sure that it's f of x minus g of x. Like I said, could have very easily subtracted f of x and just took everything to the right side, would have been g of x minus f of x. So again, it's just a little bit of luck. Okay. But if you want to just be positive, you can always just do the steps here. God bless you. Because I don't want you to see it happen 2 or 3 times and think it was always going to be the case where it always was going to equal this function here. It's pure luck sometimes, depending on which side you take all the terms. Oh, bring that over. Here we go. All right, so now all we have to do is integrate each term. Okay, so we have negative 1/4 times the integral of x squared, which is x to the 3rd power over 3, plus 1/2 times the integral of x, which is x squared over 2, plus the integral of a constant is just that constant times the independent variable. That's from x equals -2 to x equals 4. All right, so all we have to do now is apply the fundamental theorem after we simplify it. I'll do that first. So negative 1/4 times 1/3, that's negative 112 x to the 3rd. Plus 1/4 x squared. Plus 2x. Okay. Again, you could have applied it up here, but sometimes it's just easier to simplify it first. So apply the fundamental theorem of calculus. Okay. I try to be specific because there are a lot of fundamental theorems out there. Okay, so now we plug in our upper bound. We have negative 112 times 4 to the 3rd power plus 1/4 times 4 squared plus 2 times 4 minus, we go ahead and plug in our lower bound. So that's negative 112 times negative 2 to the 3rd power. Plus 1/4 times negative 2 squared plus 2 times negative 2. So we know that 4 to the third power, 4 times 4 is 16, 16 times 4 is 64. So we have negative 64 over 12 plus 4 squared is 16. 16 divided by 4 is 4. Plus 2 times 4 is 8. Okay, minus, we have negative 2 to the third power, which is negative 8. So negative 8 times negative 1 over 12 is positive 8 over 12. But we distribute this negative and it makes it negative 8 over 12. Okay, so negative 2 squared is positive 4. Positive 4 times 1/4 is positive 1. But when we distribute that, it makes it minus 1. We have 2 times negative 2 is negative 4, but as soon as we distribute, it becomes positive 4. Okay. And then from here, we can just simplify by combining like terms. Okay, so negative 64/12 minus 8/12 is negative 72/12. And 8 plus 4 is 16, minus 1 is 15. And assuming they want the exact answer, we can change that from negative 72 over 12 plus multiply 15 by 12 over 12, and that gives us 180 over 12, which just simplifies to 108 over 12, which is just 9. So that one turned out to be a nice, neat answer. All right, any questions on that one? No. All right. Okay, anyone still writing? Okay. Okay, so let's say that R is the region. Actually, let me, instead of R, just to kind of switch it up a little bit, let's say Q. Because sometimes they'll do that, and it's the exact same steps. Absolutely nothing changes. But I don't want you to get so comfortable with R that a different variable kind of throws you off. It means absolutely nothing. Okay, so Q is a region bounded by the functions f of x equals 3 minus 4 times the square root of x. And g of x, I'll put it down here, it just doesn't look like it's enough room, is a negative 4, make that a little smaller, Negative 4/3 x plus 1/3. Find the area of that region Q. Remember, when it doesn't tell you which one it bounds from above, or which one bounds from above and which one bounds from below, we have to find it. So we do that. Remember, since they didn't tell us, we don't know which one bounds from above. So that's always going to be the one that goes first. We find where f of x is equal to g of x. Okay, so we have 3 minus 4 square root of x is equal to negative 4/3 x plus 1/3. Okay, so we can go ahead and just subtract 3 from both sides. So we have negative 4 square root of x is equal to negative 4/3 x. You have 1/3 minus 3, which is negative, well, you might as well say 1/3 minus 9/3, which is negative 8/3. Move that negative 3 up a little bit. Just so it's not into the next step. There we go. Now, if you wanted to, you could divide both sides by negative 4, but we don't have to, only because we want to get rid of that square root. And as long as we have the square root term by itself, we don't have to get rid of the coefficient, but you can if you wanted to. Now all we have to do is square both sides. So we square this side, and we square this side. Okay. So remember, you want to square each side. You don't want to square each term. It's completely different steps. So you want to make sure you square the entire right side and the entire left side. You don't want to square this side and then go negative 4/3x and then square that one and then square that one. That'll throw off everything. You want to make sure you square the entire side on both sides. So negative 4 times the square root of x squared. Well, negative 4 squared is negative 4 times negative 4, which is 16. And square root of x squared, well, the square and the square root cancel each other out, so that's just x. And that's equal to the negative 4 over 3x minus 8 over 3 squared. I'll move this over here so I can work that out on the right side. I like to put my little workout notes on the right. Doesn't really matter which side it goes on, but I am a creature of habit. Okay, so we have negative 4 over 3x minus 8 over 3 squared. That's just negative 4 over 3x minus 8 over 3 times negative 4 over 3x minus 8 over 3. See if I can move it over just a little bit. There we go. 4 over 3x minus 8 over 3 times negative 4 over 3x minus 8 over 3. There we go. And then from there, we just do the FOIL method. Since we're multiplying two binomials. Okay, so we have negative 4 over 3x times negative 4 over 3x, which is positive 16 over 9 x squared. In your outer, you have negative 4 over 3x times negative 8 over 3. So that's positive 32 over 9. And then your inner, positive 32 over 9. So that ends up being positive 64 over 9 x. And your last, negative 8 over 3 times negative 8 over 3, which is positive 64 over 9. So this just becomes 16 over 9 x squared plus 64 over 9x plus 64 over 9. So again, first thing we want to do, get rid of the fractions. They just complicate problems even more. So we're going to multiply each term by the least common denominator, which is 9. So instead of rewriting it, we're just going to say we're going to multiply this one by 9, multiply this one by 9, multiply this one by 9, and multiply this one by 9. So 16 times 9 is 144, so we have 144x is equal to, multiply 9 and 1/9, those two 9s cancel out, so 16x squared plus 64x plus 64. We know it's quadratic, so we have to make it equal 0 before we can factor and solve it. So we go ahead and subtract 144x. Uh-oh, forgot my 1. From both sides, and those two cancel each other out. Okay, so we end up with 0 equals 16x squared minus 80x plus 64. But I like having my variables on the left, so I'm just going to flip them around. You don't have to if you don't want to. Just make that 16x squared minus 80x plus 64 equals 0. And again, we could solve this using a couple of different methods, but whenever possible, try to simplify it as far as you can, because you can turn something really crazy into something a little more manageable. So this one, these are all multiples of 16. So we can actually just go ahead and divide each term by 16. Or you can multiply each one by 1 over 16, same thing. Okay. So that gives us x squared minus 5x. And 64 divided by 16 is 4, is equal to 0 divided by any non-zero number, still going to be 0. Okay. So all we have to do is factor and solve this. So we have x minus 5, not x minus 5, x minus 4 times x minus 1 equals 0. Okay, so I mean, x minus 4 can equal 0, so x can equal positive 4. X minus 1 can equal 0, so that means x can equal 1. So we know just from this one that our interval is from 1 to 4. Okay. So again, we have the interval, we just don't have which one bounds from above and which one bounds from below in that interval, which is where the test value comes in. Okay. So we pick a test value in the interval. We can't pick x equals 0 because it's not in the interval. So we'll pick x equals 2. And again, it's completely random. You could have picked 3, you could have picked 1.5, whichever one you want. Okay. So this one, we know that f of 2 is just 3 minus 4 square root of 2. Just plugging it into our original function. Right, so if you plug that into your calculator, you get around negative 2.66. Now we do the same thing for our g of 2. That's negative 4/3 times 2 plus 1/3. And if you plug that into your calculator, you will get about, actually you can solve it by hand and get negative 7/3. But that simplifies to about negative 2.33. All right, well, it equals this, and it's approximately equal to that decimal. Let me clean that up a little bit. There we go. All right, so we can see here that if we look on the number line, say this is 0. We have negative 2.333 is actually greater than negative 2.66. Make that 3 a little neater. So that means that g of 2 is greater than f of 2. Which means that for this interval, g of x is greater than or equal to f of x. Which means for this one, the g of x is the first term. Right, we'll finish it up on the next page. All right, anyone still writing? Okay. So since we know that g of x is the greater function on that interval, we know to find the area of that region, the integral from a to b, is going to be g of x minus f of x with respect to x. Which means your area is going to be equal to the integral from 1 to 4 of g of x, which is negative 4/3 x plus 1/3, minus f of x, so minus 3 minus 4 square root of x with respect to x. All right, so here we can just go ahead and get rid of the parentheses by distributing that negative or that minus. Let's move that arrow down just a little bit. Here we go. Area is equal to the integral from 1 to 4 So negative 4/3 x plus 1/3 minus 3 plus 4 square root of x. So really the only two terms you can combine are the constant terms. Can't combine a square root term and a x term. So that's going to equal the integral from 1 to 4 of 4 square root of x minus 4 over 3x and 1/3 minus 3 is just negative 8 over 3. So now all we have to do is just integrate each term. Now remember, with that square root of x, you can rewrite that. Square root of x is just x to the 1/2 power. Okay, that gives us 4. So you have x to the 1/2 power, so that's the integral of that is x to the 1/2 plus 1, so that's x to the 3/2 divided by 3/2. I'm going to leave a little bit of space after that just to get rid of that fraction in the denominator. Minus 4 over 3 times the integral of x, which is x squared over 2. Minus the integral of a constant, 8 over 3 is just 8 over 3x. And that's from x equals 1 to 4. So let me move this out the way, just so it's not running into it. From 1 to 4. Here we go. So now we just want to simplify these so that when we plug in our values, we can do as little struggling as possible. So we have to get rid of that fraction in the denominator, which means we just have to multiply the numerator and denominator by the reciprocal of that denominator. So if we have 3/2, that means we have to multiply it by 2/3 divided by 2/3. Okay, well, if we multiply our denominators, we get 6 over 6, which is just 1. So those two cancel each other out. And this 2/3, we can just factor that right on over to the front. That's 4 times 2/3. And you could have go ahead and simplified that if you wanted to. I just didn't want to skip any steps. Times x to the 3/2 power. Minus, we have 4 over 6x squared. We go ahead and multiply those two. Minus 8 over 3x. From x equals 1 to 4. Yes.
Was it positive one or negative one?
Pretty sure it's positive 1. Let me double check. Yep, positive 1. All right, so this one, we could just have 8 over 3. We can go ahead and rewrite that. And that x to the 3/2 power, I'm going to rewrite that too, just to make it a little easier to work with. That x to the 3/2 power, you can rewrite that as x to the 1/2 power cubed. And we know that x to the 1/2 power is just the square root of x. So that's the square root of x cubed. Which is helpful because our upper and lower bounds are perfect squares, so it won't be too bad. Okay, so that's times the square root of x cubed. That 4 over 6, we can simplify that to 2/3 x minus 8 over 3, x squared, 8 over 3x. From x equals 1 to x equals 4. Now that we have it nice and simplified, we can go ahead and apply the fundamental theorem. Give that a little bit more room. So we can go ahead and plug in our upper bound. So we have 8 over 3 times the square root of 4 to the 3rd power. Minus 2/3 times 4 squared. Minus 8 over 3 times 4. Minus, now we can go ahead and plug in our lower bound. 8 over 3 times square root of 1 to the 3rd power. Minus 2/3 times 1 squared. Minus 8 over 3 times 1. neaten up that 3. Here we go. All right, so we can go ahead and just simplify those. Square root of 4 is just 2. 2 to the third power is 8. 8 times 8 over 3 is 64 over 3. We have 4 squared, which is 16. 16 times 2 is 32, so that's minus 32 over 3. 8 over 3 times 4 is also minus 32 over 3. Square root of 1 is just 1. 1 to the third power is 1. So if we distribute that, that becomes negative 8 over 3. We have minus 2/3, but as soon as we distribute, that becomes plus 2/3. We have negative 8 over 3, but as soon as we distribute, it becomes positive 8 over 3. And I really didn't need this bracket. Don't know why I put it there. So if we look at this one closely, we could see we really don't have to do much to it. Get positive 8 over 3, negative 8 over 3. 32 over 3 minus 32 over 3 is negative 64 over 3, which cancels out with this positive 64 over 3. So our answer is just 2/3. All right. So any questions on that one? Okay. All right, leave it up for a few more seconds. Make sure everyone's done. All right. Okay. Now we just looked at trying to find the area of a region with respect to the x-axis. We had 2 functions of x. So what if we wanted to find the area of the region with respect to the y-axis? With respect to the y-axis. Oh, let's put a comma there. So it's the same general idea. So let's say if we have our x and y axis. So instead of 2 functions moving horizontally, what if you have 2 functions that are moving vertically? Let's say if you have this function here and this function here. So we know that if our functions move left to right and pass the horizontal line test, they are functions f of x and g of x. This one, let's say if you have a function with respect to the y-axis, then that would be f of y and g of y. They're both integrating along the y-axis. Okay, so let's just draw this kind of a side-by-side comparison. Or if you have your f of x and g of x. Now, this one, we could see that if we wanted to find the region between some value a and some value b, this would be our region here. If it were bounded above by f of x and below by g of x. Okay, this is the one that's integrating along the x-axis, which is what we've been doing so far. Yes.
We take the inverse? Take the inverse?
Nope, you don't do the inverse. That was a nice assumption, but because it does look like the inverse will work. But with this one, you kind of use the same formula. You remember here you had the area is equal to the integral from a to b f of x minus g of x with respect to x. And this one was the upper function minus the lower function. So you have the upper minus the lower. But when it's along the y-axis, then instead of going from a to b on the x-axis, we're going to go from some value c to d on the y-axis. Okay. So now we have this vertical region. Move that over. This is the one that's integrating along the y-axis. And the formulas are almost identical, where the area is just equal to the integral, but instead of going from a to b on the x-axis, we're going to go from c to d on the y-axis. And if you want to call these a and b, you can. It just get confusing if you use the same ones. But it doesn't really matter what you call those variables. But just to keep things nice and as least confusing as possible, along the x-axis we use a and b, and we use c and d for the y-axis. Okay. And instead of going the upper function minus the lower function, this is going to be f of y minus g of y with respect to y. And this is just the function on the right minus the function on the left. all the steps are very similar, but they're kind of tweaked just to accommodate the fact that it's integrating along the y-axis. Now, the biggest difference is, let's say if they gave you a problem and it said and they just gave the function x is equal to 3y plus 7 and x is equal to 7y plus 8 or something like that. If it's already solved for solved for x, then you could just use them the exact same way you would do these here. But a lot of these aren't already solved. They'll give you two functions with respect to the x-axis and want you to find the area with respect to the y-axis. So a lot of them will kind of switch it up. And we'll do an example of that. Hey, anyone still writing? All right. Oops, there we go. So let's say, for example, if we wanted to find the area of the region that is bounded by the function, well, functions, f of x is equal to x squared minus 7x plus 12. Uh-oh, there we go. And g of x is equal to negative 6x plus 42. And the x-axis. Make that plus 12 a little neater. There we go. Integrating with respect to the y-axis. And x is greater than 0. Probably could have broken that down to 2 sentences. Seems like an awful lot of ands thrown in there. Didn't even notice it before now. Now, the same way, if we wanted to, we can say instead of f of x equals this, we could say y is equal to this function and y is equal to this function. Instead of explaining them as a function of y, we now have to convert them both to functions of x, because remember, x is equal to f of y, the same way y is equal to f of x. Y is equal to f of x, and x is equal to f of y. So we now want to solve for y and convert these functions with respect to y. Okay. Now the trickier out of the two is going to be f of x. So we're going to express both functions as a function of y. So instead of f of x equals x squared minus 7x plus 12, we're going to write that as y is equal to x squared minus 7x plus 12. Okay, which means we have to isolate and solve for those two terms. We have to be able to solve for x. So probably the most efficient way to do that would be to complete the square. Not the only way to do it, but probably the one that is the least amount of work. Okay, so we know that for this function, a is equal to 1, b is equal to -7, and c is equal to 12, because it is in the form y equals ax squared plus bx plus c. Excuse me. So remember, if you wanted to complete the square, just CTS. That's just b divided by 2a squared. Well, b is equal to -7. So that's -7 divided by 2 times a, so that's 2 times 1 squared. So that's just -7 divided by 2 squared. Negative times negative is positive, so that gives us 49/4. So that value here, we're going to add and subtract it. Okay, so what that does is that we can now take this and rewrite it as y is equal to x squared minus 7x plus 49/4 minus 49/4. Plus 12. Make that 9 a little bit neater. There we go. Okay. The reason that helps is because now these three terms created a perfect square trinomial. So as long as you remember the value just before you applied the square, you can turn those three terms, since that's -7/2, as x minus 7/2 squared. Okay, now only thing left to do is just add these two. And we can do that over here on the side. Okay, so we have -49/4 plus 12. We already know we can't add or subtract fractions unless they have the same denominator. So we'll just make that -49/4 plus 48/4. Since 48 divided by 4 is 12. So if we add those together, we just have -1/4. Okay, so these two terms just gives us -1/4. So since we want to solve for x, we have to get rid of, well, we have to isolate the x. So we can go ahead and add 1/4 to both sides, where those two cancel each other out. Make that 1/4 a little neater. Here we go. So that gives us y plus 1/4 is equal to x minus 7/2 squared. Let me change my pencil lead. There we go. Okay, and just to get rid of that fraction here, because later on it's going to be a little bit of a headache, we're going to multiply every term by 4. Okay, which means we're going to multiply this term by 4, this one by 4, and this one by 4. That gives us 4y plus 1 is equal to 4 times x minus 7/2 squared. So now we can go ahead and solve for x, because all we have to do is square root both sides. Yeah, I'll write it next here. Okay. Now remember, when you square root both sides using the square root property, you have to remember your plus minus. So we can go ahead and square root this side. And we can square root this side, and it doesn't matter which side you put the plus minus. But since we are solving for x, we're going to put the plus minus on this side. Okay, so we have plus or minus the square root of 4y plus 1 is equal to, we have the square root of 4, which is 2, times the square root of x minus 7 over 2 squared. Well, that square and square root cancel each other out. That's just x minus 7 over 2. And just kind of show you what I did over there. All I did was take the square root of 4 times x minus 7 over 2 squared. And we can separate that to the square root of 4 times the square root of x minus 7 over 2 squared. We know that the square root of 4 is just 2. And again, the square and the square root cancel out, leaving just x minus 7 over 2. So if you wanted to, you could distribute the 2 first and then move everything to the right, or you could just divide both sides by 2 first, completely up to you. I'll go ahead and divide both sides by 2 since it's already factored out. And I'm running out of space on this page. All right, anyone still writing? All right. Just to show where we left off. So we have x minus 7 over 2 is equal to plus or minus square root of 4y plus 1 over 2. Okay, so we have plus or minus square root of 4y plus 1 over 2 is equal to x minus 7 over 2. Okay. So if we add 7/2 to both sides, that gives us x is equal to, make that a little neater, equal to 7/2 plus or minus the square root of 4y plus 1/2. And again, I like to have my variable on the left side. Square root of 4y plus 1 divided by 2. Now, this is the crazy thing. If you actually, you can go to Desmos or you can use your graphing calculator, but Desmos is probably easier. If you have your original function, let's say, I'll use y. Y is equal to x squared minus 7x plus 12. Okay. Now that function, when you graph it, it'll look something like this. Well, should have been a little better centered, but it looks something like that. Might not be on the y-axis, but it'll look something like that. Actually, let me draw it just by itself. Okay. And if on the very same graph, or you can open up a new graph, completely up to you. If you plug in x is equal to 7/2 plus the square root of 4y plus 1/2. That graph will actually just be the right side of this one. That'll look like this. And if you plug in x is equal to 7/2 minus the square root of 4y plus 1/2, that graph would just be the other half of it. It would look like that. Okay. That's the odd part of it. Is that those three functions, this one is identical to these two when you combine them. Okay. Was that thunder? Couldn't tell if that was thunder or a truck. All right. So with this one, because we know this graph will cross the y-axis, this part of the graph we can't use. And the reason is because if you look at the very first group of stipulations, x has to be greater than 0. So when you graph this one, you'll see that this value of x would be less than 0. It's on the left of the y-axis. So we can't use this one. Okay, so we can only use since we know that this graph is actually greater than 0. Oh, bring that down. So there we go. And we kind of separate those two a little bit. There we go. Okay, so this one right here we cannot use. for that same reason. X has to be greater than 0. Okay, so we found our x is equal to 7/2. Yep. Plus or minus the square root of 4y plus 1/2. Okay, so, oh, not plus or minus, plus. There we go. Okay, so we found one. Now the other one is pretty easy. And I don't throw the word easy around too much, but this one was pretty easy. Okay, so this is the first one. The second one, your g of x. Remember, that was y is equal to negative 6x plus 42. So for this one, all you have to do is subtract 42 from both sides. So we have negative 6x is equal to y minus 42, or y minus 42 is equal to negative 6x. So if we divide each term by negative 6, those two cancel out. So we have x is equal to negative 42 divided by negative 6 is positive 7 minus y over 6. Okay. So the second function to solve for x was pretty easy. It was that first one that'll give you nightmares. So now we have to find the interval, and remember, to do that before, we had to find where the two functions intersect. Well, they intersect each other whether you're going along the x-axis or the y-axis. So because we could make these two equal, but that will be a little bit of a headache. So what we can do is we can make the f of x equal g of x, and then just plug that value in. Or plug it in and find our y value. Okay, and since this is kind of a little extra note, I'll put a box around that one. Find where the functions intersect. Compare the, I don't want to say compare, that doesn't, let's say just equal the two original functions. Compare doesn't really sound as clear. Okay, so what that does is that tells us the x-coordinate of where they intersect. So once we know the x-coordinate where they intersect, we can use that to find the y-coordinate where they intersect. And once we find that y-coordinate where they intersect, we'll have our leftmost and rightmost bounds. Okay, so again, we're going to go with the f of x equals g of x. So f of x is x squared minus 7x plus 12 is equal to negative 6x plus 42. So we got to make this equal 0. We add 6x to both sides, where those two cancel each other out. And we subtract 42 from both sides, where those two cancel out. Okay, so that gives us, make that a little neater, x squared, negative 7x plus 6x is minus x, plus 12 minus 42 is minus 30, is equal to 0. Right. So using the zero factor property, we just factor the left side. So x squared minus x minus 30 is x minus 6 times x plus 5. Which means this is true when x is equal to positive 6, or x minus 6 is equal to 0 when x is equal to 6. And x plus 5 is equal to 0 when x is equal to negative 5. But once again, those may be two of our solutions, but we cannot use this one because x has to be greater than 0. So we know they intersect when x is equal to 6, which doesn't do us much good because we need to know where they intersect with respect to y, but we can still find that. We just plug this into either one of our y functions. Okay, so out of the two, the g of x function is the easier to work with, so we'll just use that one. It gives you the same answer for either one. Okay, so again, we can use our g of x function, but we'll just call it y. Was that y equals negative 6x? There we go. Plus 42. So if we plug in that x equals 6, so that's negative 6 times 6 plus 42. So we have negative 36 plus 42, which means that y is equal to 6. So we found one of our bounds. We don't know if it's the upper or lower just yet, but we found one of them. And we don't really have to find the other one, only because they told us right at the very beginning that it's bounded by the function f of x, g of x, and the x-axis. And we know the x-axis is just y is equal to 0. So they told us that one right at the very beginning. So they'll give you little breadcrumbs of hints. which is the x-axis. Okay, so we know that our interval is from 0 to 6. And remember, that's your, because we're integrating with respect to the y-axis, that's your C to D. Now, the same way we had to plug in a test value to find out which one was the upper bound and lower bound, we do the same thing here to find out which is the rightmost function and the leftmost function. So the process is pretty similar. Just a few little tweaks along the way. And I'll do that on the next page. I don't want to try and cram all of that on here. Excuse me. All right. Anyone still writing? All right. Okay, so we just plug in a test value. Find the rightmost function in the interval. Okay, so we know that from y equals 0 to 6, or y is an element of 0 to 6. We can pick any number in there. Again, I'll just pick a test value. Y is equal to 1. Again, that's completely random. You can pick whichever value you like. So if we have x is equal to, I'm trying to remember. Seven over 2 plus the square root of 4 times y. So 4 times 1 plus 1 divided by 2. And you have x is equal to, where's the other one? 7 minus y over 6, so 7 minus 1 over 6. Okay, so if you plug this into your calculator, you end up with approximately negative 2.38. And if you plug this, actually you can just do this one by hand and you end up with 41 over 6. But if you plug that into your calculator, you get about 20.5. So if you put these both on a number line, this would be the far most right. Oh, let's say furthest right. So we know just the same way that the function with respect to the x-axis, if it's more than the one below it, then the one that's on top is the one that comes first in the equation. Same thing here. Furthest right, we know this one is first in the equation. Okay, so we know that this is actually your g of y. We can say that this is your f of y. Only because this started out as the g of x. That's the only reason. We renamed it g of y. So that means that our area is equal to the integral from c to d of g of y minus f of y with respect to y. So we had to go through all of that before we could even start the problem. So. Thing is, the integral seems like the easy part now. It's the setup that usually takes most of the time. All right, so now we can just go ahead and plug everything in. The integral from c to d, so why did I put a parenthesis there? That should be bracket. The integral from 0 to 6 of g of y, which is 7 minus y over 6, minus your f of y, which is the square root of 4y plus 1 over 2 plus 7 over 2 with respect to y. I can't really see the glare. We've got a few minutes. Okay, so if we simplify this by distributing, we have the integral from 0 to 6, 7 minus y over 6 minus the square root of 4y plus 1 over 2 plus 7 over 2 with respect to y. Go ahead and combine those two terms. Yeah, the area is equal to the integral from 0 to 6, negative 1 over 6 y minus 1/2. We can just factor out that 2 times the square root of 4y plus 1. We could just rewrite that as 4y plus 1 to the 1/2 power plus 7 over 2. Okay, so we're almost done, I promise. So the area is equal to, we can go ahead and integrate each term. That's negative 1/6 times the integral of y, which is y squared over 2, minus 1/2 times the integral of 4y plus 1 to the 1/2 power. So when we have that one, we have to use the u substitution. U is equal to 4y plus 1. So we have 4y plus 1 to the 3/2 power divided by 6. 4y plus 1 to the 3/2 power divided by 6 plus 7 over 2y. And that's from 0 to 6. So from there, we just have to apply the fundamental theorem. Move that over a little bit so we have enough room. So we have -1/12 times 6 squared minus 1/2 times 4 times 6 plus 1 to the 3/2 power divided by 6 plus 7/2 times 6. Minus, since that's 0, we know that this would just become 0. Minus, and you have to be careful with this one because this just becomes -1/2 times 1/6. You still have that 1 in the numerator. So that becomes -1/12 plus 0. All right, so if we simplify, we get -36/12. 4 times 6 is 24, plus 1 is 25. So you have the square root of 25 to the 3rd power, which is 5 to the 3rd power, which is 125/12, plus 42/2, plus 112. Once we distribute that negative. And if we combine like terms, we just multiply this by 6/6. We just end up with 92/12, which simplifies to become 23/3. And I was trying to beat the clock. Sorry, I kept you over a few minutes. All right, so it's a little bit lengthy, but some of the problems get a little bit crazy. They kind of take you back to a lot of the stuff you maybe had a class or two ago. All right, so if you have any questions, feel free, hang back, ask away. If not, I will see you tomorrow. Hi.
I have a question. Like
Sure.
those quizzes, where do we take those? Like,
They will be online too.
okay, so it's just when you assign them?
Yeah.
Okay, and then are like the exams multiple choice, or like are they random?
Some of the problems will be multiple
Like
choice.
for the final and like all that, it's like
All right, you too.
is it like written or like multiple choice?
Some will be multiple choice. All right, you too.
Yeah.
But some will be
Yeah.
like fill in the blank
Like
where you have
yeah,
to solve
like
it.
the conceptual.
Yeah.
Okay. And then I think I have one more, but I might have forgot. Well, if I remember, I'll ask you tomorrow.
All
Thank
right.
you. Have a nice day.
You too.
The lectures will be uploaded, right? Like after like 4 to 5 minutes.
Oh, yep. And like I say, usually about 10, 15 minutes. It
Yeah,
just,
'cause
for
I'm-
some reason, it takes a minute for them to process it.
All right. Because on Thursday, I'll probably have to leave early because I have to take my mom to the doctor's appointment. So,
Oh, okay.
all right. I just
All
wanted
right.
to let you know.
All right. Thank you. Hey.
Is there like usually a curve on the final, or is it like just
Uh,
the scale?
Normally, the curve is applied to the overall grade.
Okay.
So, like I said,
Okay.
even
Do
instead
you know
of
what
just
that is like usually? Or
it
is like,
varies.
It depends.
Yeah,
All right.
normally I just get the grades, calculate the standard deviation, and kind of get it from there. So
Okay.
it,
Thanks
I
so
really
much.
won't know until like
Yeah. Of course.
right there.
Yeah, yeah. All right. You have a nice day. Thank you.
You too.
Tell
Hey.
me you didn't go to college right out of high school.
Oh no. No, I was actually.
the first day of class.
Oh
It's
no,
like,
I went from high school. I was a dishwasher, then I was an oil change tech, then I was a mechanic for like 8 years, and before I finally decided to go back to school. So
I was an oil change tech. I was a mechanic. I've been an engineering tech. I've fixed everything you can possibly think of. I just got to working on robots for a magnet.
Yeah.
And not a ham. I take boxes out of bigger boxes, put them in that slightly smaller boxes for Amazon. And I won't be doing anything else until I graduate.
I don't blame you. Like I said, sometimes it takes a the long way to get there, but
I have 2 classes left. I'll be done with my bachelor's degree in computer
Nice.
science. But I want to go to. I'm looking at Penn State's
Mhm.
electrical engineering program, computer engineering
Nice.
program. Sorry. So that's my goal.
oh man, that's nice. Congratulations.
The reason I can't go here is because if you see me leave class, my wife's birthday.
Oh, okay.
So and it's
Congrats.
any day now. So if I just
So
leave,
you
now,
watching the phone like a hawk.
Yes. It's our 3rd, so it's not like.
Oh, okay.
All right, well, thank you.
All right, you're welcome.
Yep, see you tomorrow.
All right, see you tomorrow. Hello.
I just had a quick question. I didn't know for this part. You got negative 2.38 and 20.5. Am I doing my math wrong? I got 4.6 for that, and for the 41 divided by 6, I kept getting 6.8.
Oh, let me check. All right. So minus. Yeah, how did I get that one? I think I may have mixed up. Maybe. Oh, I should look at this one.
I don't think it would make like the biggest difference because this one would
Yeah, I think it'd still be
the bigger
bigger.
one.
Yeah, I would like to know how I wrote that down. Do. See if I can find it. Ah, here we go. Oh, wrong page. Oh, here it is, right here, looking right at me. Hold on, I may have mixed up. Because I always saw them ahead of time, and I think I might have just.
I usually make like really dumb mistakes, and that's why I'm like, I want to make sure I'm not.
How did I get that? I think I wrote this. I'm glad you pointed that out. I'm trying to.
Okay.
I'm trying to figure out how.
But it's actually
how
a
I did
valid
that.
thing because with the -1 thing, I just like mixed up my signs, and that's why. And so I was like, oh, it's probably one of those again.
I think I know what I did wrong. I think I put minus there. That's what I did wrong. Okay. If that was just me plugging it in absent-minded.
I got you. Thank you.
Pointing that out, I did.
Thank you for like going over it because I was like, I do sign things. I'll make up random numbers. So I'm like, okay, I'll just make sure I'm not the one.
Nope, you were right. I think when I plugged it into my calculator, I did the -1 instead. So let me check that one. 7 minus 1 was 6. I could have just picked a different x value.
That would make sense.
I think it was that one.
Okay.
Probably. I think when I did my example, I picked a different x value.
But that's why it still works.
Yeah, that's why it still
it'll
works.
Still give you,
Yeah.
like, the other one as the bigger. I got you.
So instead of sticking to what I did before, sometimes I'll just venture off into a whole new set of steps. It'll still work, but
Okay.
the answer that I have here that I worked out earlier is just a little bit different than the one.
That's fair.
Yep, that's it. Okay, but that's why it still worked.
Thank you so much.
You're welcome. Thank you.
Yes, of course.
Sure.
I'm pretty sure somebody asked you it like as you were leaving, but I didn't hear your answer.
Mm-hmm.
Are the quizzes gonna be like online or in class?
Online.
Online.
Yeah.
Okay. And then I had another question.
Sure.
But thank you for answering my question.
Oh, you're welcome. If you remember it, just write it down and ask me tomorrow.
Have a good day.
You too. Oops, put that over here.